Today we're going to learn about section 3.4 on finding the arc length of a circle as well as finding the area of a sector in a circle. Both of these deal with a part of the whole thing. A part of the circumference, a part of the area of the whole circle. And we're going to think about it in that way. The book presents it as going from the formula of the radian, which is theta equals the arc length over the radius, and then you multiply by r on both sides, so arc length equals r times theta. So they're going from here back to there. And so that's one way to find the arc length, but the problem is theta has to be in radians to do this. If it gives it to you in degrees, you cannot apply that formula. I'm going to explain that there's probably a better method of doing that, and that's either one of two methods. One is part over whole equals part over whole. Or the second way is going to be the percentage of the whole. And you're going to see when I talk about specifics here that this first one is going to lead into the second one. And if you work with this part over whole equals part over whole, it will work for every single problem in this section. And then you're not going to have to adjust or freak out when you have something that's different than the specific one that fits into the whole. This problem right here is like a huge Ferris wheel, and you're on the radius of it is 125 feet. And 125 feet is going to be this length. And you know that this is a 45-degree angle. And the question really is, what is the length of that arc? How far do you move on that Ferris wheel if you know that the angle is going to be 45 degrees in the center? You could use the formula in the book that just says S is equal to R times theta, but if you put 45 in for R, you're going to get the wrong answer because R has to be in radians. So that only works with radians. So therefore, I'm really not going to think about doing it that way. If you do want to use that, that's totally fine. But the way I want to think about it is put my arc length first and set it up as a proportion. Arc length over, so it's part over the whole. The whole is going to be the circumference. So it's part of the circumference over the whole circumference, 2 pi r, is equal to part of the central angle over the whole central angle, which is 45 degrees over 360 degrees. Part over whole equals part over whole. And then the question really is just solve for this S by multiplying both sides by the denominator. So it would be S equals 45 over 360 times 2 pi r. Now, there are two ways of thinking about this problem. The first way is this proportion. The second way is that the arc length is a percent of the area of the circumference. Arc length is a percent of the circumference. If you want to do part over whole equals part over whole, you start with this. If you want to go right into here, you could just say it's a percent of the whole thing or the circumference and do it that way. This should make sense in terms of setting it up. This formula, to me, doesn't make sense. It makes sense if you know the formula for the radian, or the definition of a radian. But again, you're going to have to juggle it around. And you can do every single problem this way. At this point, the question is, well, I'll just put use my calculator and simplify it. you should be able to do it two ways. You should be able to use your calculator and get an approximation around to the hundredths, or you can simplify and solve for the exact answer, which I prefer. And so the arc length equals, and what I would do is I would just take 2 into 360 to make it 180. And therefore, it's going to be, 9 goes into here 5 times, 9 goes into here 20 times. Well, 5 goes into here once and 4 here. So to make a long story short, it's going to be 125 pi over 4 is the exact answer for the arc length S. The same problem can be done with 105 degrees instead of 45. Basically what you're doing is you're changing that number right there and everything else is the same. That's arc length. The other type of problem that you can encounter is a clock. And let's say this is a clock. We'll just do it in inches. And so you have a minute hand at the center, and you're going to see that the minute hand is going to move, and the minute hand is 1.2 inches. So the question on this one is, what is your S? Your S is how far it moves, the tip of that hand moves. The answer is going to be, again, you can set it up as part over whole equals part over whole, or percent of the whole thing. Part over whole equals part over whole, we're looking at what we're trying to find, which is my S. I always like to start with that first. S is to the whole circumference, 2 pi r, 1.2, is equal to, and then again what I want to do is think about, okay, well in the last problem, it was the center. The center I don't even know, but I have to know the other part of this problem, which is it moved for 20 minutes. Now, this is the same type of problem with a clock hand moving for 20 minutes because it's a part of the whole. Or the other idea is you could have a satellite going around the Earth. If it takes 8 days to get around and you're on day 2, you now have a part of the whole. Okay, so this is part over whole equals part 20 minutes out of 60 minutes, part over whole. Right? 20 minutes compared to the whole thing. That ratio is the same, and now again what you could do is go ahead and solve for S, and that's going to be 2 pi 1.2 divided by 3. Notice that you could also think about this in terms of proportion, but you could also think about it in terms of percent of the whole. This is really 1/3. 20 over 60 is 1/3. 1/3 of the circumference has to be this right here. And that's what I have right here. 1/3 of the circumference is percent of the whole, and that's going to give me my answer for S as well. Again, if it's decimal, you can figure that out. If it's not, you can leave pi in, and that would be minutes. That completes the arc length. The second topic is the area of a sector. The area of a sector is where your central angle is at the center of the circle, and it's going between 2 points, A and B, and you want to find out what the area is of that. And so let's go ahead and figure this one out. Again, same idea, part over whole equals part over whole, nothing changes. The book does this and gives you a shortcut, but in my opinion, you don't have to use that. If you want to use it, then you can go ahead and use it. But to me, it makes more sense doing this. So, area of the sector of the area of the whole circle equals the central angle over one full rotation. If you're dealing with degrees, it's over 360. If you're dealing with radians, it's over 2 pi. This only works if you're dealing with data in terms of radians. I've seen a lot of mistakes with using degrees, and it's a memorization. That's why I prefer to do it part over whole. All right, we're going to do 2 problems with the area of a sector, and we're going to set them up the same way. So let's go to this one and see if we have, we're saying that theta is equal to 15 degrees, and I'm giving my area of the sector is pi over 3. So it's not finding the area anymore, it's actually giving me my area. Well, you do the same thing, and the question here is, what is my radius? All right, so I have area is equal to, so that means area pi over, no, what do I have here? Yeah, the area is what I want to find, so it's going to be pi over 3 over the whole area, which is going to be pi r squared equals area of the sector over the whole area of the circle equals, and now what I want to do is write down the theta, which is my central angle, 15 over 360 degrees. Setting it up is the same way our focus is to solve for that r right there. Notice I didn't have to change this to radians because it's part over whole. To solve for my r, I can cross multiply and solve for it, so this becomes pi over 3 times 360 equals pi r squared times 15. Then I can simplify this by having 3 go into 360. I can divide both sides by pi. And then I want to divide both sides by 15. And you're going to see that r squared is equal to 8. Then I take the square root of both sides. Remember, it has to be plus or minus. However, your radius is positive, so you're dealing with a 2 squared equal to 2. So the radius in this case is 2 squared root of 2. Nice, exact answer. This has some nice algebra to go through. Again, the focus, set it up as part over whole, and you can do all these problems. The last one is a little bit easier, and you're going to see that you have the area of the sector of a sprinkler. And the sprinkler is going to be 90 degrees. It's going to shoot the water through 90 degrees, and the length is going to be 30 feet. And the question is, what is the area that you get? Now, again, I would not use what the book has. I would just say, well, to me, this could make sense that this is only going to be a quarter of the circle of the area of the circle, right? 90 over 360 times the area of the circle. It's the percent of the area of the circle. You could think about it that way. Or you could do part over whole, part over whole. The question is, what is the area of the sector? So A over pi r squared equals 90 degrees over 360. It's pretty easy to solve after you set that up. This becomes 1/4. Area equals 1/4 pi 30 squared. Area equals, let's see, this is exactly 225 pi, or you can round to the nearest hundredth, so however you want to do it. And that would be feet squared. Keep in mind, the book does it one way. I think it's easier to set up all the problems the same way and be consistent with it. And then you don't have to worry about if you're dealing with ratings and rebates. Just make sure they're going to the same unit. And that concludes chapter 3. We're going to have the test coming up here next week.